Ignition sequence starts.
Hello and welcome to the heart of human spaceflight in America, the Mission Control Room at NASA's Johnson Space Center. The folks you see here are monitoring the International Space Station systems and helping the Expedition 67 crew members with their work for the day. The combined American, Russian, and Italian crew is in the home stretch of a very exciting and productive week. It was full of space station science, maintenance, preparing for an upcoming spacewalk, and all the things that go into welcoming a new spacecraft on board.
Welcome to Space to Ground, I'm Chelsea Bayarte. Fireworks weren't the only lights in the sky this July. A SpaceX Cargo Dragon spacecraft has launched and is making its way to the International Space Station. SpaceX's 25th Commercial Resupply Services mission launched off the coast of Florida at 8:44 p.m. Eastern on July 14th. Our Cargo Dragon spacecraft is carrying dozens of new experiments to the orbiting laboratory. We're sending immune cells to seek new methods to treat immune system aging, an imaging spectrometer that will measure the effects of mineral dust on our planet, and a student gene experiment that could lay the foundation for downstream applications of biosensors for space exploration and resource-limited settings on Earth. Another experiment hitching a ride on the station is Beaver Cube, a small satellite expected to take color images of the oceans and thermal images of cloud tops. Collecting data on the temperatures of both could help scientists learn more about Earth's climate and weather. The spacecraft is set to arrive at the space station on July 16th. It's expected to dock around 11:20 a.m. Eastern, but we'll be live in mission control following the operation starting at 10. Be sure to catch the autonomous docking on NASA TV, your NASA app, or follow the mission on social media. If anyone were to go dumpster diving aboard the International Space Station, they might find items like packing material, dirty clothes, office supplies, and hygiene products. And that's exactly what made up the 172 pounds of trash eliminated during a test. Last week, our partners at NanoRacks tried out a new method of taking out the trash, and it was the first open-close cycle of the Bishop airlock. The process is simple. The astronauts fill the waste container, and the trash bag is released to burn up in Earth's atmosphere. The empty container is then remounted, ready for more. Even though the astronauts are busy getting ready for their upcoming cargo delivery, they still made time to catch a glimpse of the first images of the James Webb Space Telescope. NASA astronauts Kjell Lindgren, Bob Hines, and Jessica Watkins took to Twitter to share their excitement. Lindgren said it best, "They're absolutely breathtaking." That's all for today on Space to Ground. Thanks so much for watching. See you next week.
The space station crew is right. NASA's newest infrared space telescope has opened a new era in astronomy. The first set of full-color images and spectroscopic data gathered by the James Webb Space Telescope were released this week, showing the capabilities of Webb's 4 state-of-the-art scientific instruments, all now in full operation after launch this past December. You can see the images in more detail and read all about the mission of this partnership of the space agencies of the United States, Europe, and Canada at nasa.gov/webfirstimages. We are not ready to send astronauts 1 million miles out from Earth like where Webb is, but we are getting closer to sending astronauts to the moon as part of the Artemis program. And we're making progress in developing new hardware for their moonwalks. Last month, NASA announced contracts with 2 private companies to design and produce new spacewalking suits. On the International Space Station, astronauts are supporting an experiment that's evaluating an active thermal control technology for those new suits.
Imagine you are on the moon. Your job for the next 8 hours will be exploring, traversing up and down lunar hills, sampling rocks, and setting up equipment. Temperatures can reach a blistering 250 degrees Fahrenheit. Luckily, you have a portable life support system, a backpack that provides oxygen, water, power, and for the excruciating temperatures, a cooling system. Under the Artemis program, NASA and its partners are planning to return astronauts to the moon, and the agency is testing new spacesuit technologies. As a new age of exploration heats up, engineers are looking to improve how to keep astronauts cool in space. Outside the International Space Station, astronauts perform extravehicular activities, EVAs, also known as spacewalks. During the Apollo era, spacewalks took place on the lunar surface, and with the Artemis program, humankind will once again return to live and work in the harsh environment of the moon. Future plans call for spacewalks to last longer and be more demanding, not just on the astronauts, but also on the spacesuits and systems that protect them and keep them alive and healthy. NASA has been working on advanced technologies needed for next-generation spacesuits. NASA's reference design, the Exploration Extravehicular Mobility Unit, or the XEMU, features greater mobility, visibility, and flexibility. This prototype is just the beginning. To meet the needs of future exploration as part of the Artemis program, NASA will share its newest designs, research, and data with commercial industry, whom NASA will partner with to build the next-generation spacesuit. It is an effort that will benefit from NASA's most recent studies and the agency's 50-plus years of spacewalk experience. Spacesuits are essentially a spacecraft made for one. They have many important life-preserving components, but none is more complex than the system to regulate the temperature of the astronaut. Engineers call this cooling system the thermal control loop.
The thermal control loop is part of the portable life support system, or the backpack that the astronaut wears when they do an EVA. The thermal control loop is designed to keep the astronauts cool. When the astronauts are doing spacewalks, they can be exposed to extreme temperature swings, say up to 250 degrees Fahrenheit. The thermal control loop is part of a system that consists of a liquid cooling ventilation garment, or LCVG, that the astronauts wear under the spacesuit. It consists of tubes that are filled with water that circulate from water pumps in the backpack to keep the astronauts cool.
During the Gemini program, engineers realized that astronauts not only needed protection from the temperatures of space, but also from the heat generated inside the suit, from their own bodies as they worked. Originally, the suit designers thought that airflow over the astronaut's body would keep temperatures regulated. What they discovered was that air cooling in a spacesuit is insufficient to do that job. During the Apollo era, it was decided running cool water through a garment that covers the body could help keep the astronauts from overheating. The means of cooling the astronaut was now an essential life-sustaining element to the spacesuit and was here to stay. The spacesuit currently in use on the space station, developed in the 1970s, also uses a water-cooled garment. Circulating water is still the best way to cool an astronaut. However, improvements can be made on how to move that water through the system, using new technologies and materials to test how to make the essential cooling system safer and more reliable than ever before. The result of this research is SERFI, the Spacesuit Evaporation Rejection Flight Experiment, all the critical elements of a spacesuit cooling system in one box. 2 SERFI units have been built, one to work here on Earth in our gravity, and another SERFI unit meant to be tested in the absence of gravity, in space. On board the International Space Station, astronauts take advantage of the microgravity environment to perform a variety of science experiments and to test exploration technologies. When engineers developed the spacesuits for the Apollo and Space Shuttle eras, NASA did not have a space station in operation. Today, the station presents a perfect platform for engineers to use microgravity to put the SERFI cooling system to the test.
In that experiment, we will test a couple different versions of the water pump that will be used to circulate the water through the system. We'll test temperature sensors, we'll test pressure sensors, integrate all those into one little package and test them for long duration to see how they'll perform over the expected life of a spacesuit.
SURFy shows how the water will move through the system as if it were inside a spacesuit, cooling the astronaut. But a spacesuit cooling system needs to do more than just circulate water. As the astronaut works, their body generates heat, which is transferred into the liquid cooling and ventilation garment. A thermal control loop needs a way to remove the heat from the water that is circulating through the system. That's where SWIMMY comes in, the spacesuit water membrane evaporator.
SWIMMY consists of some porous hollow fiber membranes that are contained in a metal manifold. When warm water flows through the porous membranes and then is exhausted into space, the cool water continues through the porous fibers and continues to flow through the LCVG liquid ventilation garment to cool the astronaut.
With the means to run a cooling system and offload heat and gases, the SURFy unit runs for 8 hours at a time, the span of what a spacewalk might last in space or on the moon. The tests are run again and again, simulating the rigors of what a spacesuit thermal control loop might encounter during its life cycle. Astronauts take water samples from SURFy for analysis. Just as a spacesuit might sit in storage for a time between spacewalks, like during a trip to the moon or Mars, SURFy is sometimes switched off. This time of dormancy is when contaminants can grow in the system.
That's when the bugs, the microbes, grow in the water system. And those little guys grow and they reproduce and they can grow through the system. They'll clog your filters, and once your filters get clogged, the water stops flowing.
When the water stops flowing, the suit stops cooling. Contaminants in the water are such a problem for current spacesuits that astronauts set aside time for regular water maintenance chores every 90 days. The SURFy tests hope to demonstrate that new technologies and materials will be far more robust in working through water contamination issues, reducing the risk of the cooling loop failing.
We don't want to have to worry about water quality. We want to be able, we've joked among the team, we want to be able to pour chicken soup into the exploration EMU and it'll still run the way it's supposed to run. Even if there's microbes in there that the system doesn't care. So we want the filters to catch the microbes, and if the filters don't catch the microbes and they flow through the pumps don't even notice the microbes or the contamination or whatever's in the water. They keep operating the way they're supposed to operate. We want our crews to be spending their time exploring, not running maintenance procedures on our spacesuits.
All the testing for SURFy in space is duplicated on Earth, with a twin SURFy running in 1G, Earth's gravity. By testing here and simultaneously testing in the microgravity of the space station, engineers can infer how the cooling unit will run in the 1/6 gravity of the Moon, the 1/3 gravity of Mars, and all points in between. The knowledge gained from building and testing the twin SURFy units is already paying off, as work is underway building a full-size backpack for NASA's prototype exploration spacesuit.
How's it going to perform in microgravity? Well, by sending SURFy to space station, we can actually test how it's going to perform in microgravity. That in itself buys down the risk. So now there's one less unknown that we have to worry about when we send our hardware off to do what it's supposed to do.
I am so excited that SURFy, SWIMMY is on orbit, that we're working great, our ground unit is working great. SURFy has made a difference. We've had engineers, scientists, thermal analysis, water experts. It's been an exciting multi-discipline collaboration.
It's a collaboration that will inform spacesuit technologies for the moon and beyond. A new design for a thermal control loop and its ability to help regulate temperatures for astronauts during exploration can benefit from the data gathered from SURFy, making it one cool little experiment.
The International Space Station hosts experiments in a whole range of classic scientific disciplines. And there are also things like research into using 3D printing technology to manufacture biological materials in microgravity. This could allow cell growth in 3 dimensions.
Cutting-edge biomanufacturing aboard the International Space Station. Presented by Science at NASA. Most likely, you're aware of 3D printing, which allows you to design and produce one-of-a-kind pieces for a variety of purposes. But what if you could use that same technology to manufacture biological materials, like new tissue or blood vessels? Welcome to the world of 3D biomanufacturing, a cutting-edge practice on Earth that is being tested aboard the International Space Station, or ISS. Dr. Mike Roberts, Deputy Chief Scientist at the ISS U.S. National Laboratory, explains why the space station is critical to biomanufacturing's future. We've been able to grow cells in a lab for well over a century, but gravity limits that growth to 2 dimensions. Cells can grow outward, but not up and down like they do in the human body. Also, lab cells are often in contact with the glass or plastic that contains them. But aboard the space station, our experiments will be conducted in microgravity. That allows you to build your cell models in 3 dimensions, without being confined to the bottom of a dish, or unable to grow in contact with lots of other cells. Biomanufacturing imagines the ability to someday grow a viable human organ. Organs are composed of specific tissue intersected by blood vessels. Most organs and thicker tissues in the body have a rich, complex network of blood vessels that provide nutrients and remove wastes from the living cells that make up the tissue. We currently lack the ability and the tools to engineer these highly branched, living networks of vessels inside layers of tissues on Earth. Another medical advantage to manufacturing biological parts in space is the potential to bypass the body's immune system. Today, organ transplants from donors are prone to rejection because the patient's body perceives the new organ as a foreign object, and their immune system tries to attack it. But with the ability to grow tissue in space, a person could conceivably have their own cells used to make their new organ, which might avoid the body's rejection. 3 different types of biomanufacturing facilities will be tested aboard the space station. 2 of them perform in a manner similar to a standard 3D printer. They extrude cells in layers to build tissue. The 3rd type uses powerful magnets to position the cells in place. Each of these 3 different approaches to bioprinting in microgravity will be available to medical researchers seeking to better understand how to engineer tissues and organs for use in repairing injury and curing disease on Earth. As Dr. Roberts notes, the 3D bioprinters represent cutting-edge technologies that could clearly benefit health outcomes on Earth. I think the ability to manufacture a fully functioning human organ will take some time, maybe a decade or more, but the knowledge we'll acquire to get there will also create interim benefits as we learn more about cell regeneration in space and its application to humans on Earth. For more inside information about studies inside the station, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.
The first astronauts to walk on the moon, the Apollo astronauts, brought back more than 800 pounds of lunar soil. Those samples have been stored and dispensed for research by a NASA lab here at the Johnson Space Center in Houston. Take a look at that facility and how it's getting ready to care for the next generation of lunar samples, those that will be brought back to Earth by Artemis astronauts.
For over 50 years, NASA astronauts and scientists have explored the universe, searching for ways to study the elements and materials that make up the solar system. In NASA's early days, the Apollo astronauts walked the lunar surface to collect moon rocks and soil for study back on Earth. In all, Apollo explorers sampled 842 pounds of lunar material. Today, those precious samples are curated within NASA's Astromaterials Research and Exploration Science Division, or ARES. Many of those lunar samples are stored in their Lunar Sample Laboratory facility at NASA's Johnson Space Center in Houston, Texas. NASA curators work to preserve the samples for ongoing and future scientific research. The samples are protected in secure and environmentally controlled vaults. Each sample is sorted by mission and stored in Teflon-based bags that are kept in cabinets filled with nitrogen gas. To this day, scientists from around the world study and analyze the samples to answer important questions about the moon's formation and history. To preserve their integrity, NASA curators follow strict safety and handling processes when working with samples. It begins with a laminar airflow change room. This minute-long air shower keeps the labs where they work pristinely clean. Ares scientists must also wear special gear, including a whole-body, non-particle shedding polyester bunny suit and triple-layered gloves. They also use custom tools to protect the samples. Moon rocks may only be touched with Teflon, aluminum, or stainless steel tools, and the dry nitrogen atmosphere around them. This allows curators to carefully examine samples while maintaining their original condition. This process ensures the samples are not contaminated or destroyed and can be used to produce scientifically accurate results. Technological advancements, including next-generation microscopes and other devices, allow researchers to examine the samples through new methods, resulting in important discoveries that answer some of our oldest questions. Soon, NASA's Artemis missions will land the first woman and the first person of color on the moon, and Ares plays an important role. Our researchers, scientists, and sample curators look forward to the upcoming missions and the opportunity to study new samples of lunar material. As NASA returns to the moon, it brings us closer to landing the first humans on Mars. Following in the footsteps of Apollo and Artemis missions, the next generation Mars explorers will have the opportunity to see, touch, and collect off-world soil and return it to the Earth for study. This work will usher in a new era of exploration and discovery. We are scientists, researchers, and explorers. We are Ares.
The men and women who have had the opportunity to go to space and get a first-hand look down at the expanse of the entire planet Earth often talk about how fragile it looks. In this episode of Down to Earth Conversations, astronaut Sunny Williams and environmental studies student Adrian Prouty discuss the things we should be doing to take care of this miracle planet.
After viewing Earth in orbit, do you feel like it has fostered a greater sense of sensitivity towards the well-being of our planet and the planet's environment for you?
Oh my gosh, yeah. I mean, when you look at that planet, like I said, from the first time I saw it out the windows of the shuttle till, looking out the cupola or going out for a spacewalk, I mean, you just can't help but thinking, like going back to the very beginning, like there are people down there, and those people are not only people. Heck, there's trees and plants and animals that are on that planet, and the only reason that they're there is because this miracle that has our planet have all the right things at this time, right? Mm-hmm. And so everything that we know and we love is only here because of the way the planet is in its lifetime at this moment in time. So you can't help thinking about, we're pretty bold to think that we should have the right to change it, let it change over time. I mean, we are like one planet in our solar system. You know, our sun is only gonna be around for so long, a little longer than you and I will be alive, so that's sort of convenient for us, but maybe inconvenient for later. But, you know, our planet is gonna evolve as it should, and we should be really good stewards of it just to make sure that it does it as naturally as it does it for the sake of all the living things on this planet. And our planet is alive too. I mean, that's what's, I think, really super compelling from space. You can actually see it, you know, not like on a daily basis, but on a yearly basis, you know, specifically pictures from space 10 years, 20 years, 30 years ago, we can see things changing. Some of it just as it does for itself, some of it as a reaction to us. And I think we should be conscientious of what our impact is and try to minimalize that as much as possible so that we can all live on this planet happily and healthily. Like I said, not only the humans are only one part of it, but everything else that is on our planet.
So we've been traveling into space, maybe not for a very long time, but for a bit. Do you think this is a similar experience that astronauts, even in the past, and anyone who's been able to have that same perspective on our planet, do you think that they have had a similar feeling, and how do you think that that has evolved through the decades?
Yeah, I'm sure they have. But in the very beginning, before we had satellites, we probably didn't have as many, overarching views of what's going on over the long term. In geological time, it's a blink of an eye, but over the long term for our human existence here, I think it's becoming more and more obvious that we have an impact. Like I mentioned, I think folks all need to take the lap around the planet, because then you can see, the frailty of it. Like our atmosphere is so thin. It's ridiculous. I think, when we look up to the sky, we think, there's plenty of, oxygen to breathe, we're fine. When you step away from the planet and you see that's just this little thin layer, and that's it between, we're only at 250 miles above the Earth, and it's a totally inhospitable place to be. It's hot, super cold. Obviously there's no oxygen, it's a vacuum of space. You cannot live there unless you have a space station, and that is very fragile as it is. I think you probably know we're always doing maintenance on the space station, so we're always fixing it. So there's no way we could really sustain ourselves in space. So we need to really take care of our planet, and it's the place that we all live and where we're from. We absolutely need to take care of it. You're into the environment, and
yes.
Everybody should be. And I'm
yes.
so proud of you at your young age to be thinking about that, have that on the forefront of your mind. It's pretty cool.
I think I'm particularly interested in the environment because, yes, the planet, I love it. If we want to keep living and we want everybody to keep continuing to have the full lives that they deserve and have the same thirst for life, we need a planet that can give us that kind of shelter.
Yep.
And that's a two-way relationship. Any passions, I think, music, science, whether it's in space or on our planet, you can't really have those passions if you don't have a planet to live on to experience them. And I think that's kind of what connects all people.
Yep. I agree. I think everybody wants to have a happy life,
yes.
healthy life.
A happy, healthy life, exactly.
Yeah, and we all deserve it, but we all have to take responsibility. I love what
yes.
you said. It's a two-way street.
Yes.
It gives us so much. We need to give back.
As we keep doing maintenance on the space station every day, we need to do that back to our planet.
Yep, exactly.
Beautiful.
If you want another look at any of the stories we showed you today, you can head on over to YouTube and Facebook at those addresses right there, and you'll find them all, along with lots of other great features on a wide variety of NASA topics. And you can get the latest from all over NASA delivered straight to you every week, like this week's Webb telescope images. If you go to nasa.gov/subscribe to sign up for the NASA newsletter.